Welcome to Mathematics Academy. So in today's video, I'm going to be taking you through introduction to probability. Probability refers to the chances of an event occurring, the likelihood of something happening. We use probability to measure uncertainty, event that occurs at random. We use probability to determine the possibility of that thing happening. Your result in probability must be from 0 and 1. A probability result cannot be more than 1. A probability result cannot be less than 0. That is to say, it is very wrong if you solve a problem for us on probability and your result is negative, or your result is above 1. Let's say you are getting 1.1, 1.2, 5, 6. It means that your result is wrong. Now, when a probability result is 0, it means that that event is not going to happen. And when a probability result is 1, it means that for sure that event is going to happen. Probability results can be expressed as decimal numbers, as fractions, as percentages. We can even use words to express our probability results. You must note that the probability of success plus the probability of failure is equal to 1. The general formula we are going to be using to solve problems on probability is going to be probability equal to number of required outcome all over the number of total possible outcomes. So in short form, I will be writing required outcome all over total outcome. So when I say required outcome, you know I'm referring to number of required outcome. And when I say total outcome, you know I'm referring to number of total possible outcome. So let's take the first example to explain further, to explain better what probability is all about. So example number 1. This question is a very good example that will explain better what we mean by probability. The first thing to do is to write down your formula. Probability is equal to number of required outcome all over number of total outcome. Let us identify the parameters in this question. Number 1, it talked about a market trader has 400 oranges. It means total oranges is 400 for sale. He said 8 of them are bad. Number that are bad is 8. Okay, if 8 oranges are bad, it means that to know the number that are good is for you to just remove 8 from this 400. So I can now say number that are good, total oranges 400 minus 8 bad oranges 8. This is going to give us 392. So it means there are 392 good oranges. So these are the numbers that are good. This is the number that are bad. And this is total oranges. Now, but the question is asking us, what is the probability that it is a good orange? That means our required outcome will be good orange. Our total outcome will be what? The total number of oranges. So let's now solve the problem. Probability of good oranges. So our required outcome is the numbers that are good, which is what? 392. 392 divided by our total outcome. Total outcome is total oranges, which is 400. 400. 4 go here, 100. And 4 go here, 98. So this is equal to 98 divided by 100. So this will give us 0.98. That means that the probability of getting good orange is 0.98. So let's solve this problem. The first thing I would advise you to do is, first of all, to write down what I call your parameters. Okay, here we have how many balls? Red balls, 6. We also have white balls, 10. We also have blue balls 9. So total balls 6 plus 10 plus 9. That will give us 25. So the next thing to do is to write down your formula. Probability, required outcome, all over what? Total outcome. The first question is asking, what is the probability that the ball is red? So we go, so probability of red balls, in short form, probability of red balls is equal to required outcome. Look at our formula, required outcome. What do we require in this question? We require the number that are red balls. We go back to our parameters. How many red balls do we have? 6 divided by the total outcome. So what is our total balls? 25. So breaking down into decimal, 0.24. Question B. Question B is the probability that the ball is green. So we go probability of green ball is equal to, remember the formula. So what is the required outcome here? Green balls. So how many green balls are here? 0. Divided by total outcome is what? 25 balls. So 0 divided by any number will give us 0. When your result is 0, it means that that event cannot happen. It is not possible for Excel to pick a green ball. That is why the probability of getting a green ball is 0. Okay, let's go to the question number C. Not white ball. In probability, or means plus, while and means multiplication. Probability of not white ball. It simply means remove white ball. If we remove white balls, that means it is not the probability of red balls or blue balls. The probability of red ball or blue balls. This is equal to probability of, so let me break it down into one. Probability of red ball plus probability of blue balls. So let me finish up here. So this is equal to probability of red ball simply means required outcome is red over what? Total. That is to say, our red ball is how many? 6. All over total outcome is what? Total ball is what? 25. Plus the second one is probability of blue balls. So how many blue balls do we have here? 9. All over total number of balls, which is what? 25. So this is equal to the LCM of 25 and 25 is 25. So 25 go here, 1. 1 times 6, 6. Plus 25 go to 25, 1. 1 times 9, 9. So this is equal to 6 plus 9 will give us 15 over 25. So this is equal to 5 go here, 5 go to 15 will give us 3. And 5 go to 5 will give us 5. So 3 over 5 in decimal number 0.6. Question number D. The probability of neither red nor blue. Red nor blue. So this means the probability of neither red nor blue means remove red balls, remove blue ball. Look, so look at this. Not red balls, not blue ball. Then it means it is what? White balls. So it is something as probability of white balls. So our required outcome is what? White balls. So how many white balls do we have here? 10. All over total outcome. So our total balls here is what? 25. So our answer becomes 5 go here, 5. 5 go here, 2. Our answer becomes 2 over 5, 0.4. All right. So do you see how simple probability problems could be. So it is all about understanding the question you were asked and then being able to apply the formula properly. Remember the formula, probability is equal to required outcome all over total outcome. So example 3 says the probability that Kamsi will pass his examination is 0.69. Find the probability that he will not pass. Okay, remember I told you earlier on that the probability of success plus the probability of failure is equal to 1. So the first thing I would like us to do is to write down our parameter, probability that Kamsi will pass is equal to 0.69. Now let's do this little arithmetic. I want to use P to represent pass, and I want to use F to represent fail. Remember, I told you from the introduction that the probability of success plus the probability of failure is equal to 1. That means the probability that Kamsi will pass plus the probability that Kamsi will fail is equal to 1. But in this question, they have given us that the probability that Kamsi will pass is 0.69. That means it is certain as saying 0.69 plus the probability that Kamsi will fail is equal to 1. What am I supposed to do here next is to collect like terms. If 0.69 that is positive goes across the equal sign, it becomes negative. So that means that my F is now equal to 1 minus 0.69. So this will give us 1 minus 0.69 will give us 0.31. So the probability that Kamsi is going to fail his exam is 0.31. And I say, therefore, the probability that Kamsi will fail will be equal to 1 minus 0.69. So this will give us 0.31. So I believe that with these few examples we have solved, we have been able to understand the introduction into probability. Thank you so much for watching. See you in my next video.